Hello, everyone. Air power changed warfare forever, but it also created a new problem. Once aircraft could strike cities from hundreds of kilometers away, defending the sky became just as important as controlling it. Since the 1950s, the United States has developed dozens of surface-to-air missile systems designed to destroy enemy aircraft, cruise missiles, and even ballistic missiles. From the early Nike missiles guarding American cities to modern interceptors capable of striking targets in Spa. After the Second World War, the United States faced a new strategic reality. Nuclear weapons and long-range bombers created the possibility of sudden attacks against major cities. Traditional anti-aircraft artillery could not reliably stop high-speed aircraft flying at high altitude. Military planners began searching for a technological solution. Guided missiles controlled by radar appeared to offer that solution. During the early Cold War, large investments were directed toward developing surface-to-air missile systems capable of intercepting hostile aircraft before they reached American territory. MIM-3 Nike Ajax. MIM-3 Nike Ajax became the first operational surface-to-air missile system deployed by the United States. It entered service in 1954 during the early Cold War. The missile was designed to intercept high-altitude strategic bombers approaching American cities. Nike Ajax used radar guidance and a three-stage propulsion system. The missile could travel at speeds above Mach 2 and reach targets nearly 48 kilometers away. Launch sites were built around major urban areas across the United States. At its peak, more than 200 Nike Ajax batteries protected American airspace. The system marked the beginning of the American missile-based air defense era. CIM-10 Beaumark. CIM-10 Beaumark represented a very different approach to air defense. Entering service in 1959, the missile functioned almost like an unmanned interceptor aircraft. Beaumark used ramjet propulsion that allowed it to reach speeds close to Mach 3. The system could travel hundreds of kilometers toward incoming bomber formations. Guidance came from ground radar networks linked to Continental Air Defense Command systems. Some versions carried conventional warheads, while others were equipped with nuclear payloads. These nuclear warheads were intended to destroy entire groups of enemy bombers. Beaumark became a central element of North America's Continental Air Defense Network. MIM-14 Nike Hercules. MIM-14 Nike Hercules was developed as a powerful successor to Nike Ajax. The missile entered service in 1958 and quickly replaced many earlier defense sites. Nike Hercules offered dramatically greater range and destructive power. Its engagement distance exceeded 140 kilometers. The missile could intercept aircraft flying at high altitude and later gained limited anti-ballistic missile capability. Some variants were equipped with nuclear warheads to counter large bomber formations. Hundreds of Nike Hercules batteries were deployed throughout the United States, Europe, and Asia. For many years, the system formed the backbone of Western air defense. RIM-2 Terrier. RIM-2 Terrier became one of the first surface-to-air missiles deployed by the United States Navy. The system entered service in the late 1950s as naval warfare entered the missile age. Terrier allowed warships to defend themselves against hostile aircraft at much greater distances than naval guns could reach. Early versions used beam riding guidance, while later models adopted semi-active radar homing. The missile was installed on several guided missile cruisers and destroyers. Terrier significantly expanded the defensive capabilities of naval task forces operating far from land-based air defense networks. RIM-8 Talos. RIM-8 Talos was one of the largest and most powerful naval surface-to-air missiles ever constructed. Entering service around 1960, the missile used ramjet propulsion to achieve extremely high speeds. Talos could intercept targets at distances exceeding 100 kilometers. Because of its size and complex radar guidance system, the missile was primarily installed on large missile cruisers. Later variants gained limited surface attack capability during the Vietnam War. Despite its massive size, Talos demonstrated the effectiveness of long-range naval missile defense. RIM-24 Tartar. RIM-24 Tartar was developed as a smaller and more flexible naval air defense missile. Entering service in the early 1960s, Tartar equipped destroyers and frigates that lacked space for larger systems like Talos. The missile used semi-active radar homing to track enemy aircraft. Tartar provided reliable medium-range defense for naval task forces. Its compact design allowed it to be installed on many types of warships. Over time, the technology behind Tartar contributed to the development of the standard missile family that followed. MIM-3 Hawk. MIM-3 Hawk became one of the most successful battlefield air defense systems ever developed. Introduced in 1960, the Hawk missile was designed to protect ground forces and military installations. The system used semi-active radar guidance to intercept aircraft at ranges of roughly 40 kilometers. Hawk batteries included radar units, command centers, and mobile launchers. Continuous upgrades improved radar performance and missile accuracy over several decades. More than 25 countries eventually adopted the Hawk system. Its long service life made it one of the most widely deployed Western surface-to-air missile systems. FIM-43 Red-Eye. FIM-43 Red-Eye became the first widely deployed American man-portable air defense missile. The system entered service in 1967 as a lightweight weapon designed for infantry units. Red-Eye used an infrared seeker that tracked the heat signature of aircraft engines. Soldiers could carry and launch the missile from the shoulder without requiring large radar systems. Its effective range was relatively short, generally around 4 to 5 kilometers. Despite these limitations, Red-Eye provided frontline troops with a new defensive capability against low-flying aircraft and helicopters. The system marked the beginning of portable air defense missile technology in the United States. MIM-46 Mauler. MIM-46 Mauler was an ambitious attempt to create a highly mobile battlefield air defense system. Development began during the early 1960s as the U.S. Army sought better protection for armored formations. The Mauler system combined radar, fire control equipment, and missile launchers on a single tracked vehicle. Each vehicle could detect and engage enemy aircraft independently. The missile was designed to intercept targets within approximately 10 kilometers. However, the program faced serious technical challenges during development. Costs increased while reliability remained uncertain. Eventually, the Mauler project was canceled, but the technologies explored during the program influenced later short-range air defense systems. MIM-72 Chaparral. MIM-72 Chaparral was introduced in 1969 as a simpler replacement for the canceled Mauler program. Instead of developing a completely new missile, engineers adapted the AIM-9 Sidewinder air-to-air missile for ground launch. Chaparral used infrared guidance to track the heat signature of aircraft engines. Launchers were mounted on tracked vehicles that could move with armored units on the battlefield. The missile had an engagement range of roughly 9 kilometers and was particularly effective against low-altitude aircraft. Chaparral remained in service for decades and was exported to many Allied nations. The system became a key component of American short-range air defense. FIM-92 Stinger. FIM-92 Stinger replaced the earlier Red-Eye system and dramatically improved portable air defense capability. Entering service in the early 1980s, Stinger introduced advanced infrared and ultraviolet guidance technology. This allowed the missile to track targets more accurately and resist countermeasures such as flares. Stinger could engage aircraft and helicopters at distances of up to 8 kilometers. The system gained worldwide attention during conflicts in the 1980s, where it proved highly effective against low-flying aircraft. Its portability and reliability made it one of the most widely used man-portable air defense systems in history. Modernized versions of Stinger remain in service today. MIM-104 Patriot. MIM-104 Patriot became one of the most important long-range air defense systems developed by the United States. The system entered service in 1981 and introduced advanced phased-array radar technology. Patriot batteries could track and engage multiple targets simultaneously. The missile was designed to intercept aircraft and cruise missiles at significant distances. Later upgrades expanded its role to include ballistic missile defense. Patriot first saw combat during the Gulf War in 1991 and has since been deployed in numerous conflicts. Today, it remains one of the most widely exported and widely deployed air defense systems in the world. RIM-66 Standard Missile SM-1. RIM-66 Standard Missile SM-1 represented the next generation of naval air defense missiles, following earlier systems like Tartar and Terrier. Introduced during the late 1960s, SM-1 offered improved reliability and greater engagement range. The missile used semi-active radar homing to track airborne threats. SM-1 was deployed on a wide variety of U.S. Navy destroyers and cruisers. Its versatility made it suitable for defending entire carrier strike groups from hostile aircraft. Many Allied navies also adopted the SM-1 system. For many years, it served as a fundamental component of naval air defense doctrine. RIM-67 Standard Missile SM-2. RIM-67 Standard Missile SM-2 introduced significant improvements over the earlier SM-1 design. The missile entered service during the late 1970s and early 1980s. SM-2 was closely integrated with the Aegis combat system installed on modern U.S. Navy warships. This integration allowed ships to track and engage multiple aerial targets simultaneously. The missile featured enhanced guidance systems and extended engagement range. SM-2 became one of the primary defensive weapons carried by American cruisers and destroyers. Several upgraded variants remain operational today and continue protecting naval task forces around the world. RIM-7 Sea Sparrow. RIM-7 Sea Sparrow was developed to protect naval vessels from rapidly approaching aerial threats. The system entered service during the 1970s as anti-ship missiles began appearing in large numbers. Sea Sparrow adapted the AIM-7 Sparrow air-to-air missile for shipboard use. The missile used semi-active radar homing to guide itself toward the target. Compared with earlier naval missiles, Sea Sparrow was compact and relatively easy to install on many different ship classes. Its primary mission was to defend vessels against low-flying aircraft and sea-skimming missiles. The system became widely adopted among NATO navies. RIM-162 Evolved Sea Sparrow Missile. RIM-162 Evolved Sea Sparrow Missile, often called ESSM, represented a major upgrade to the earlier Sea Sparrow design. The missile entered service in the early 2000s as naval threats continued evolving. ESSM features improved maneuverability, greater speed, and a more advanced guidance system. These improvements allow it to intercept highly agile targets, including modern anti-ship missiles. The missile can be launched from vertical launch systems used by many modern warships. ESSM became a key defensive weapon for both American and Allied naval fleets. Its rapid reaction capability makes it essential for protecting ships operating in contested environments. RIM-116 Rolling Airframe Missile. RIM-116 Rolling Airframe Missile, commonly known as RAM, was designed as a close-range defensive weapon for naval vessels. The system entered service during the 1990s. RAM was specifically created to defeat incoming anti-ship missiles that had already penetrated outer defensive layers. The missile uses a combination of passive radar and infrared guidance to track targets automatically. RAM launchers are compact and can be installed on a wide range of ships. Once launched, the missile rolls during flight to improve stability and guidance accuracy. Today, RAM serves as one of the final protective layers for many naval vessels. NASAMS. NASAMS, the Norwegian Advanced Surface-to-Air Missile System, introduced a highly flexible approach to ground-based air defense. Developed through cooperation between Norway and the United States, the system relies heavily on American missile technology. NASAMS uses the AIM-120 AMRAAM missile, adapted for ground launch. The system entered service in the late 1990s and can engage aircraft and cruise missiles at medium ranges. NASAMS launchers are connected through a network of radars and command centers. This networked architecture allows the system to track multiple targets simultaneously. One NASAMS battery is responsible for protecting the airspace over Washington, D.C. AN/TWQ-1 Avenger. AN/TWQ-1 Avenger provides mobile short-range air defense for ground forces. The system entered service in the late 1980s and mounts Stinger missiles on a Humvee vehicle. Avenger combines missile launchers with optical targeting systems and machine guns for close protection. The vehicle can move quickly across the battlefield and deploy rapidly when threats appear. Avenger units are often assigned to defend armored formations, airfields, and logistical hubs. The system specializes in intercepting helicopters, drones, and low-flying aircraft. Its mobility makes it particularly valuable in fast-moving combat environments. Terminal High Altitude Area Defense. Terminal High Altitude Area Defense, commonly known as THAAD, was designed to intercept ballistic missiles at very high altitudes. The system entered operational service during the 2000s. THAAD uses powerful radar systems combined with hit-to-kill interceptor missiles. Instead of using an explosive warhead, the interceptor destroys its target through direct impact. This method increases interception accuracy and reduces the risk of debris containing hazardous materials. THAAD batteries are capable of defending large regions against incoming ballistic missiles. The system has been deployed in several strategic locations to strengthen missile defense networks. Standard Missile-3. Standard Missile-3, or SM-3, expanded missile defense capabilities into space. Developed as part of the Aegis Ballistic Missile Defense Architecture, SM-3 intercepts ballistic missiles during their mid-course phase. The interceptor is launched from Aegis-equipped destroyers and cruisers. Once outside the atmosphere, the missile releases a kinetic kill vehicle that collides with the target at extremely high velocity. SM-3 does not rely on explosives to destroy the incoming missile. Instead, it uses the energy of impact to eliminate the threat. Upgraded versions of SM-3 significantly increased interception range and capability. Standard Missile-6. Standard Missile-6, commonly known as SM-6, represents one of the most advanced naval interceptors ever developed by the United States. The missile entered service during the 2000s as part of the evolving Standard Missile family. SM-6 uses an active radar seeker derived from the AIM-120 AMRAAM missile. This allows the weapon to engage targets beyond the ship's radar horizon using external sensor data. The missile is capable of intercepting aircraft, cruise missiles, and certain ballistic missile threats. Its multi-role capability has made SM-6 a key component of modern American naval air defense strategy. Patriot, PAC-2. Patriot PAC-2 was one of the first major upgrades to the original Patriot missile system. Introduced during the late 1980s and early 1990s, the upgrade improved both radar performance and missile guidance. PAC-2 interceptors carried larger fragmentation warheads designed to destroy incoming ballistic missiles and aircraft. The system became widely deployed during the 1991 Gulf War. Although originally designed to intercept aircraft, PAC-2 significantly expanded Patriot's ability to counter tactical ballistic missiles. Many countries operating Patriot systems adopted the PAC-2 configuration during the 1990s. Patriot, PAC-3. Patriot, PAC-3 represented a major technological shift in missile interception philosophy. Unlike earlier Patriot missiles that relied on explosive warheads, PAC-3 used hit-to-kill technology. This meant the interceptor destroyed incoming ballistic missiles through direct collision. The missile itself was smaller than previous Patriot interceptors, allowing more missiles to be loaded onto each launcher. PAC-3 entered operational service in the early 2000s. Its improved accuracy made it far more effective against ballistic missile threats. Today, PAC-3 remains a critical component of modern American missile defense systems. Patriot PAC-3MSE. Patriot PAC-3MSE, or Missile Segment Enhancement, further expanded the capabilities of the PAC-3 interceptor. Introduced during the 2000s, this upgraded missile features a larger rocket motor and improved control surfaces. These changes significantly increased engagement range and altitude. PAC-3MSE allows Patriot batteries to intercept faster and more maneuverable ballistic missile threats. The interceptor also performs better against cruise missiles and advanced aircraft. Many modern Patriot operators are gradually upgrading their systems to use the PAC-3MSE configuration. Aegis Ballistic Missile Defense. Aegis Ballistic Missile Defense represents one of the most sophisticated missile defense architectures ever created. The system is built around the powerful Aegis combat system used on modern U.S. Navy destroyers and cruisers. Aegis integrates radar, command networks, and interceptor missiles into a single coordinated defense structure. Ships equipped with Aegis BMD can detect and track ballistic missiles over extremely long distances. Interceptors such as SM-3 are then launched to destroy the incoming threat. The system forms a crucial part of the broader American and Allied missile defense network. Medium Extended Air Defense System. Medium Extended Air Defense System, known as MEADS, was designed to create a highly mobile and networked missile defense architecture. The program began during the early 2000s as a cooperative project between the United States, Germany, and Italy. MEADS used advanced radar systems and distributed command networks to detect threats from multiple directions. The system was designed to intercept aircraft, cruise missiles, and tactical ballistic missiles. Although the United States eventually withdrew from full production, many technologies developed during MEADS influenced later air defense programs. Indirect Fire Protection Capability. Indirect Fire Protection Capability, commonly called IFPC, reflects the newest direction in American air defense development. The system was designed to protect military bases from emerging threats such as drones, cruise missiles, and rockets. IFPC integrates modern sensors, command networks, and modular launchers capable of using multiple interceptor types. Unlike traditional air defense systems, IFPC focuses on defending against smaller and more numerous threats. The system continues to evolve as new technologies are introduced. It represents the next stage in the ongoing effort to protect military forces from aerial attack. Air defense technology has evolved dramatically over the past 70 years. Early systems were designed primarily to destroy large formations of strategic bombers. Modern threats are far more complex. Today's air defense networks must counter cruise missiles, ballistic missiles, drones, and stealth aircraft simultaneously. American engineers responded by creating layered defense systems combining long-range interceptors, mobile battlefield defenses, and naval missile shields. Radar systems, sensors, and command networks now work together to track and engage threats at multiple stages of flight. From the first Nike Ajax batteries guarding American cities to modern interceptors capable of destroying missiles in space, the development of U.S. surface-to-air missiles reflects a continuous technological competition. Each new generation introduced improvements in guidance, speed, and detection capability. These systems have become a central element of modern military strategy. As aerial threats continue to evolve, the technology behind air defense missiles will continue advancing as well.